the scientific community when the Large Hadron Collider recently found something entirely new. The discovered object is so elusive that some scientists have described it as a ghost. What has the collider just discovered? Why did it remain hidden for so long? In this video about the mysteries of the universe, we bring you how scientists just announced that the Large Hadron Collider has found something for the first time ever. Many people go about their day without knowing about the Large Hadron Collider. However, the discoveries made by the massive apparatus affect the life of everybody in the universe. Take as an example the latest particle that scientists just spotted for the first time with the help of the infrastructure. The Large Hadron Collider, or LHC, is the biggest and most powerful particle accelerator ever built. Covering an underground circular tunnel that is nearly 17 miles in circumference and costing billions of dollars, it is located at the European Particle Physics Laboratory Cern in Switzerland. But what exactly is a particle accelerator and why is it needed? It is a device that boosts subatomic particles to enormous energy in a controlled environment. This allows scientists to study the interaction that comes after. So basically, LHC helps scientists to test theoretical predictions and see if they have any loopholes. The LHC can be used to reproduce scenarios, including the conditions within a billionth of a second of the Big Bang. These include conditions that have never existed naturally since a few microseconds after the Big Bang. This facility is so key to modern scientific research that if there is any headline about subatomic particles, the LHC will most likely be involved. So when headlines across the world said physicists had detected ghost particles for the first time inside an atom smasher, it was obvious what equipment they used. Neutrinos are notoriously elusive, which is why news of the discovery made waves. The particle in question, the neutrino, opens up a completely new window for scientists carrying out subatomic research. They came a step closer to understanding the roles neutrinos play in the universe. While neutrinos are not easy to spot or catch, they are numerous in the universe. For instance, while you watch this video, about 100 billion neutrinos pass through each square centimeter of your body. But of course, you won't feel their entry or exit. These tiny particles are everywhere. They originate in nuclear fires produced by stars, supernova explosions, cosmic rays, radioactive decay, and more. Neutrinos manage to go undetected because they have zero electrical charges and nearly zero mass as well. They are 6 million times lighter than an electron. They almost don't react with any form of matter, but move at almost the speed of light. It is this elusive nature that makes people liken them to ghosts. But of course, if you try hard enough, you can catch neutrinos, but you must try very hard. A few experiments before now have discovered neutrinos. These include Japan's Super Kamiokande detector, Fermilab's Mini Boon, and the Antarctic Ice Cube detector. They all used a method known as the Cherenkov radiation, which is actually an indirect way to detect neutrinos. This is the gist of using the Cherenkov method to detect neutrinos. When a plane travels faster than the speed of sound, it creates a sonic boom. Similarly, when a particle travels at the speed of light through a light-slowing medium like water, it produces a faint blue glow that follows it. Scientists look for this glow when a neutrino strikes an atomic nucleus directly. However, this method only detects the signatures of neutrinos as they pass through the Earth coming from the Sun. It doesn't, for example, give any insight into the type of high-energy neutron that is produced when particles smash into each other, as can be observed in a particle accelerator like the LHC. On its own, the LHC cannot detect neutrinos. This is partly because the collider employs magnets to direct particles around a circular collision path with the detectors dotted around these curves. These magnetic traffic signs don't impact chargeless particles like neutrinos. As a result, they shoot off the edge of the detector path. To investigate this, scientists under the Phaser collaboration created a new neutrino detection mechanism, which they named the Phaser NU. This Phaser NU is made from dense metal plates of lead and tungsten. These plates sandwich some layers that can detect light, known as an emulsion. The first step is to make the neutrinos crash into the atomic nuclei on the metal plates, which produces particle byproducts. The next step is a familiar one for older photographers. The emulsion byproducts react with the neutrino byproducts, which imprints the outlines of the particles as they pass through the emulsion layers. When they developed the emulsion and analyzed the particle trails left behind, The researchers realized that some of the marks were produced by neutrinos. In fact, they were able to determine which of the 3 particle flavors of neutrino they had detected. The flavors are tau, muon, and electron. This result assured them that they had picked the right spot inside the gigantic LHC ring to detect neutrinos, and also that their new detector was actually able to see them. Phaser NU is better